So one of the things that we've introduced and been doing in this chapter is solving multivariable equations for one of the variables. These are kind of simple because there's only two variables and they're x and y. We seem to be more comfortable with this. But we've had lots of different examples of where you're solving for one of the variables. For this first one, it says solve for x. You'll notice this equation only has the single variable x. So when I solve for x, this will be a number, right? It'll be a particular value. So I'm going to subtract 22 from each side. Um, let's see, 12 minus 22 should give me negative 10. So I get that 2x is negative 10. And if I divide by 2, we get that x is negative 5. So if I plug that into the top equation, 2 times negative 5 is negative 10. And negative 10 plus 22 is positive 12. So that's the solution. That's what x is. Now let's solve the next equation for y. Okay, let me rewrite this over here. I'll write problem B, and we've got 2x minus y equals 3. We're solving for y. I'm going to take away 2x from both sides. That gives me that negative y is negative 2x and then plus 3. And if I want y by itself, right, a couple of things I could do. I'm just going to push through a factor of negative 1 on both sides. So when I push through this factor of negative 1 on both sides, I get that positive y is 2x and then minus 3. So you can see each one of these terms picked up a factor of negative 1. So just pushing that through visually, you can see y is 2x minus 3. So here I have solved for y, and my answer is an expression, right? Because I had two variables. The next one, solve for x. Interesting. If you look at this, the only variable we have is x. So let's write that down. So I've got 2x plus 15 equals 2x minus 15. And if I take away two x's from each side, you can see this is not always the end of the world, but look what this becomes. It says 15 is negative 15, which is not true, right? So there's no value of x that will make this equation true. There's no solution. Solution, right? Because the x's completely drop out, there's no way that I can use x to manipulate the left or right hand side to make these equal. It's just a fact that 15 is not negative 15. So I don't care what you pick for x. And you could sit here all day and pick values of x and like, well, what if x is 0? No, it doesn't work. Why? Because 15 is not negative 15. Well, what if x is 1? That would be 17 is equal to negative 13, and that's not true either. What if x is 2? Then is 11, right? If I put in 2 there. Oh no, if x is 2, that would be 19. Is 19 the same thing as, let's see, 4 minus 15, negative 11? No, it's not, right? So it doesn't matter what you pick for x, it's never going to be true. And then the last equation here says solve for y, and it was, I'll read this and write it down. This is part C. It says 6 times x plus 2 times y is 10. This is a nice equation, right? It's written in standard form, and we want to get y alone. So I'm just going to take away 6 times x from each side. That gives me that 2y equals negative 6x plus 10. And then I'm going to choose to multiply both sides by 1/2. It's a convenient way for me to think about this. When I do that, I know that I still get an equally valid equation. I'm just changing the form of it. 1/2 times 2 is y, and on the other side, right, 1/2 times negative 6 is negative 3x, and 1/2 times 10 is plus 5. So y equals negative 3x plus 5. So I solved for y in that equation. So that's the end of this problem.